Alright, so they want us to graph this thing. So I'm going to start by factoring it to see where my zeros are. So x squared plus x minus 6. So that's x plus 3, x minus 2. So I have zeros at, or x-intercepts at 0, negative 3, and positive 2. So 0, negative 3, positive 2. Now if I want to flesh this graph out just a little bit more, I'll plug in some points in between those zeros to figure out what's going on. If I put in a negative 4 to this thing, and here I put it in the factored form when I do it on my solutions, and it comes out really nice. You just plug it in, and if I plug in x is negative 4, looks like you get y is negative 24, so way down there somewhere. If I put in x equals negative 2, just plug it in there, it looks like I get an 8, so way up there somewhere. Negative 1, I get 6. 1, I get negative 4. 3, I get 18. 4 just gets really big. So I can see, I know it was cubic. I'm expecting the sort of noodle shape I get from cubes. And this is a gorgeous sketch. Perfect. So that's f of x. And now they want us to graph the square root of that. So square root of f of x, we're going to build off our existing graph. So we're going to say that, because all we have to do is square root all the y values. And so I do that in the table, and if I try to square root the y value down here, I'm trying to square root a negative number. You can't do that. So this graph isn't going to be defined for any of this. So my graph isn't going to start until here. The y value when x is negative 3 is 0, so the square root of 0 is 0. The square root of that y value, positive 8, is about 2 1/8. So, and you're just taking the square roots of all the y values. Square root of 0 is 0 again. And then the graph dips underneath the x-axis again. So here I'm taking square roots of negative numbers, and that's a no-no. So my graph kind of pauses here, there's nothing there. And then I start taking the square root of these numbers again. I can take the square root of 0, that's 0. And when I plugged in a 4, I get the square root of 56, which is like 7.5. Doesn't have to be perfect, just something. So when I just connect those dots, I get a little graph that goes like this. Nothing happening here, and then just comes like that. So there's the graph of the square root of the original function. Just taking the square roots of all the y values, just building off itself. It's adorable. So we got one more graph to graph, and that is 1 over f of x. So if you have 1 over f of x, what it looks like is 1 over x cubed plus x squared minus 6x. And without all the stuff we've done before, you might have learned to, where the denominator equals 0, that's where all your vertical asymptotes are. And you can compare the top and the bottom to get your horizontals and stuff like that. But here, we're going to just take it off the graph we already have. We know that where our original f of x is 0, if f of x is 0, our function is going to be undefined. So where f of x is 0, that's where my asymptotes are going to be. So I have asymptotes here, and here, and here. So hopefully this graph isn't getting too crowded. But then you're just taking the square roots of, not the square roots, 1 over all the pieces. So if I do, and again I have it here in kind of a table so you can kind of see it. when you plug in -4 to this, we got a -24 for the x, so now we're doing 1 over -24, so something very tiny. And if I did, let's see, this one you might need a little bit more to go off of. If I plugged in like a really, really big negative number here, I would get a very, very big negative number down there. And 1 over a very big number, 1 divided by 1,000,000,000, it's going to be very close to 0. So that's why you're getting this horizontal asymptote there. Because no matter what I plug in for x there, I'm not going to make it go to 0. I can't make it hit 0 because I'm always going to have 1 over something. But I want to get really, really close. So what this is going to do, this part here is going to go down and follow that asymptote down to -infinity. Because if I put in like -3.5, you'll see you're going to get a 1 over a very small number. 1 over a very small number is going to become very big. So there's that part. This part here is fairly straightforward. You're just taking 1 over all the y values of the original, sorry, of black. So when I plugged in a -2 for the x, I got 8 for the y, and 1 over 8 is an 8. So I've got a point down there, and then 1 over that. Let's see, when I plugged in a -1, I got 6 for the y, so I have 1, 6. And what this ends up doing is kind of going something like that, following those asymptotes there. This next guy does something similar. When I plugged in 1 for the x, I got a -4 for f of x, so I'm at -1/4. And then he follows those asymptotes there. When I plugged in a 1, 2, 3 for the x, I got 18 for f of x, and 1 over 18 is 1/18. Bigger x I plug in, 1 over a really, really big number, it's going to go to 0, so it's going to come get that asymptote, and then come follow that vertical asymptote up there. So, kind of ugly, a little messy, but we can do it. It does kind of end up being a plug and chug. If worst comes to worst, you just make an XY table, plug it in, and see what happens. But that's what we have.